Okay, so in this video, we are going to discuss how to conduct power analysis using G-power. First, let's review just very quickly the concept, the idea of power of a study. Now, of course, we know that a power equals 1 minus beta, and beta is the probability of making a type 2 error or false negative. In other words, power is the ability, the probability of a statistical significance test or a study to correctly reject the null hypothesis when in fact the null hypothesis is false. In other words, there is an effect, the effect is real, treatment is effective, and your study will be can correctly reject null hypothesis and conclude that the effect is real, the difference is real, etc. So that is power. Okay. And of course, we also discussed, we have talked about what are the sort of things that affect power. And three things. Number one is effect size. And the second one is the alpha level of the test. And the third one is the sample size. So effect size, intuitively, if we have a large effect, it's easier to detect something that's bigger, right? So the larger the effect size, everything else being equal, the higher the power. And the alpha level is a little more complicated. Basically, the more lenient you want to conduct the test, the higher the power. And of course, the problem with using a more lenient significance test is that you're going to make more type 1 errors. So that's which is also problematic. And the sample size, that's straightforward. We talked about that the larger the sample size, the smaller the standard error or standard deviation of the sampling distribution. So in other words, the more participants we have, the larger the sample size, the more accurate is the measurement. And as a result, the test is more powerful. Okay, so let's take a look at how the alpha level of the test might affect the power of a study. So in this demonstration, in this diagram, this part essentially, so what do we have over here? This represents this checked region. That's the probability of making a type 1 error. And this part, the one with the horizontal lines, represents the area that is the area that represents the power of a study. Okay, so that's power, which equals 1 minus beta. And we also have type 1 error. So this part is type 1 error. Now, what happens if we want to use a more restrictive, more stringent test? So that's we reduce the probability of making a type 1 error. And you notice that as the area that represents the type 1 error decreases, this part, which is power of the study, also decreases. That's, of course, it's just another way of saying this part is getting bigger. This part is beta. That's the probability of making a type 2 error. Right? So if we use a more lenient test, then power gets higher. It's a more powerful test. But the problem is that at the same time, the probability of making a type 1 error also increases. So the probability of type 1 error and type 2 errors that goes always in the opposite direction. And if we translate the probability of making a type 2 error into power, then power equals 1 minus beta. So which is why that we have, let me see, what should I have? More lenient test, more power. Large effect size, more power. And finally, the large sample size of more power. Okay, so these are the three things that affect the power. Now, what about power analysis? What does it mean when we want to conduct a power analysis? There are two kinds of power analysis that we can conduct. The one type is called a priori, which is that you conduct a power analysis before you conduct a study. And there's also post hoc power analysis. The first type, a priori power analysis, is more common. So when people talk about power analysis, usually they are referring to a priori power analysis rather than post hoc power analysis. So we're going to focus on the first type. With a priori power analysis, we basically want to know how many participants we need, how large the sample size needs to be. Well, sample size, effect size, alpha level, and power. These four things are related, which means if we know three of them, we can figure out the fourth one. Okay, so in a power analysis, we want to know sample size. Okay, so we want to know sample size. And but if we want to know the sample size, we have to know something about the other three things: effect size, the alpha level of the test, and what is the desired level of power that we want. Now, usually people would say, well, the desired level of power, the higher the better. But given that it is related to alpha level, and so we want to have a reasonable level of power. Usually, if it's at 0.80, it's considered pretty decent level of power. So the desired level of power. Alpha level is pretty much set because in psychology, the convention is to conduct the significance test at alpha equals 0.05. Now, effect size can be a little tricky. So you might say, well, before we haven't really conducted this study yet. So how would you know what the effect size is going to be? Well, we have to take a guess. We have taken an educated guess, meaning based on your reading of the theory, of the literature, previous research findings of a similar type of studies, and etc. You have to estimate whether you are expecting a large effect size or a small effect size. Okay, so you have to take a guess at effect size. You have to decide on the level of alpha, which is usually 0.05, and you have to decide what is the level of power that you want. Once you have these three, you can figure out the sample size you need. Okay, so to conduct a power analysis, we have this free software. It's called G-Power, and I have the download link. Let's see. So if you click on this, click the link, it leads you to a page. It's a free software. And so G-Power, they have a version for Mac computer, and they also have a version for Windows. So depending on what kind of a computer you have, what kind of operating system your computers run, you can just download the correct version for your computer. And there's also some additional information that I posted. Let me see over here. UCLA Statistical Method Data Analysis is a great website. They provide further examples and instructions about how to conduct power analysis using G-Power. If you are running a single sample, one sample t-test, or paired samples t-test, or independent samples t-test. And of course, some other analysis that you may want to conduct. Okay, so let's take a look at an example of actually running a power analysis using G-Power. So I already have G-Power installed on my computer. So what I'm going to do is just to switch to G-Power. Okay, so here is G-Power. And so it opens up a window. So first thing you want to make sure that you do is you want to specify what kind of test you want to conduct. So statistical test. And suppose I'm using a means. I want to test the mean difference between two independent means, two groups. So in other words, this is the independent groups, independent samples t-test. So I select the test, and I need to specify whether it's a two-tailed test or one-tailed test. So I'm going to conduct a two-tailed test. Now, what is effect size? Cohen's d. Let's say I'm just assume that we have a medium effect size. So 0.5, Cohen's d equals 0.5. Alpha level, 0.05. And we want to have power equals 0.80. Okay, and I click calculate. So the sample size, group 1, we need 64 participants in group 1, another 64 participants in group 2, for the combined 128. Okay, so now, since we have this tool, it's actually also quite interesting to see what happens if we decide to, let's say, conduct the the test at, instead of alpha equals 0.05, we want to run the test at alpha equals 0.01. Our sample size increased from 64 to 96 in each group. So if you want to be more restrictive, then the power goes down. And if you want to achieve the same level of power, you have to use more participants. Okay, so let's say we go back to power alpha equals 0.05. Now, what if the effect size is small? Instead of Cohen's d equals 0.5, how about the Cohen's d equals 0.20? That's a small effect. Everything else stays the same. Still alpha equals 0.05, power equals 0.08. Now we need 394 participants in each group for a total of 788. So if the effect size was very small, to achieve the same level of power, we need a lot more participants. Okay, so using this tool, we can also run power analysis for matched pairs, right? For matched pairs, or we can even run. Let's see, they should have, one sample case. So if it's one sample case, let's say two-tailed test, effect size medium, alpha level 0.05, power, let's say 0.80, and we can calculate. We need 34 participants for this analysis. Degree of freedom in this case equals 33. Okay, so this is the G-Power. It's a great tool if you ever need to conduct power analysis. And so again, just to refresh, just to summarize, there are four things to consider, right? We sample size, effect size, alpha level, and what is the level of power that you want. And if we know 3 of these, we can figure out the 4th one. And so if we go back to our power analysis page, this is essentially the a priori power analysis. Means we figure out what is the required sample size given effect size, alpha level, and the level of power that we want. Okay, so that is the end of this video.